In this video, we're going to be looking at the table object in WatchKit interface. So how we can add a table, how we can configure it, how we can change the appearance, and how to get data to display in the table. Now the thing to know about tables in WatchKit is that they're a little bit different if you're coming from, say, an iOS background, in that you can only have one column. You can have a number of rows, but considering the very small screen size, it does make sense that you can only have one column. And we also need to kind of learn how to do some subclassing here. So what do I mean by that? Well, you know what, let's just bring in the table and we'll kind of explore the different aspects of it and how to do some of these things we need to do. So first of all, as you can see, I'm just on my interface storyboard and I don't have any objects in there. And if we take a quick look at the code, you see that I don't have anything going on in the code either. So it's just a blank interface right now. So let's go to our objects library here. And I'm going to bring in a table. Okay, and if I click on it and wait a second, we see, okay, table displays one or more rows of data. Templates define the types of rows that can appear in the table. Your app extension provides the row data dynamically using the WatchKit interface table API. Okay, so this is kind of a hint, just by the description, that it's going to be a bit more complex than we're used to. So I have that open, and what I'm going to do is I'm going to open this kind of side panel here to show the scene and basically the objects associated inside this interface controller. So as you can see, I brought in a table, and it also brought in these kind of other aspects associated with the table. For example, it brought in a table row controller, and within that controller it has a group. Now before we get there, let's just take a look at the table object itself. So the table, we can see it has a number of properties we can adjust in our attributes inspector. The first one we can adjust is called prototypes. So you might be thinking to yourself, what is a prototype? Well, it's just basically how you add rows. So why did they call it a prototype? I'm not sure exactly, but if you look, they're basically the same thing. So they're table row controllers, each with a group inside of them. And you can add more, but we'll just leave it at one for now. And we'll come back to that. Spacing, you know what, actually just to demo spacing, I'll add two. Spacing is the space between the table rows. So usually it's okay to leave it on default. If you want more space, definitely go ahead and add more space. But I'm going to put it back to the default. That's all there is to that. Background, you could set a background image for your table if you wanted to. I'm not going to bother here, but in case you did, this is how you would do it, and you would just load an image from your assets library. Color, you can also adjust the color of your table, so the background color. So you can make it as funkadelic as you want. I'm just going to set mine back to default though. Okay. Otherwise, we have vertical detail paging, which basically enables or disables pagination. I'm not going to spend too much time on that, but if you wanted to do pagination of some sort, so page 1 of results, page 2 of results, this is where you would enable it. I'm going to leave it disabled for now at least. Otherwise, we have the standard things like alpha. So this controls the transparency or the alpha channel. So if you want to make it 50% transparent, you could do 0.5. It's hard to tell here with the black background, but this would be making it more transparent. Otherwise, you can adjust the standard things as well, like horizontal and vertical. Now, before we can get our table row to display any data, we need to take care of some other things first. Each row controller, so each row has its own controller, basically has to have a unique identifier. And we set that up in the attributes inspector. So if you notice up here, it's giving me a warning signal. And if I click on that, it'll tell me, so table row controller, and then it's just some kind of letters, is missing an identifier. So it needs to be able to identify the row, right? And this is kind of unusual. We haven't seen this kind of behavior before from Xcode. And it's telling us we need to give this some kind of identifier. Because right now, if I attempt to display some information, it's not going to be able to display it. So for example, we're going to bring in a label and put it into the group here. And let's say I wanted to see if my row is working. So this, I can tell you right off the bat, it's not going to display anything. So if you're wondering why your table, you're trying to set it up, it's not displaying anything, you need to do a couple other steps first. So while this loads up, I'm just going to kind of go back and get rid of our label here because I know it's not going to show anything. And I'll just delete it actually. All right, and just to double check our simulator, yeah, it's just blank. So we need to follow the steps to set it up. The next thing we need to do, So as you can see, before I was on the table, and that had a whole bunch of attributes we could adjust. The table row controller, well, we can't really do much. So we give it a name. We can also choose whether it's selectable or not. In other words, whether the user can tap on it or not. So every row needs a name. So let's give it an identifier here. And for this demo, let's just call it my row controller. Okay, so now it has a name. You can see over here in the scene it updated to not just say table row controller, it actually has the identifier. And I will leave it selectable. I want to be able to kind of tap on it and see a result. Okay, next thing we need to do. We need to associate this controller with a class. And to do that, I'm going to create another file here. And it's going to be basically a subclass of an NS object. So let me get rid of this side panel, for now anyway. And I'm going to bring in the panel on the left. And I'm going to create a new file here under my WatchKit app extension. This is where all our files are anyway, in case you haven't noticed. So interface controller, for example. So I will create a new file, like so. New file. Okay, and it will be a WatchKit class file. Go next. And here we can see we name the class, and we definitely want it to be an NS object. So that's what we want to do. And the class, I'm just going to call it my row controller. That's going to be the class as well as the identifier name. You know what? I'll add class to the end so it's more clear. Okay, subclass of NS object. Okay, and then it just asks where to save it, and it's just going to save it in the same kind of root folder. Right, so it is in the same folder as our interface controller. And now we see, so it has class, my row controller class is a type of NS object. And now we can associate our my row controller with the actual class. And that way at runtime, the table will create instances of the row controller classes for each row in the table. So let's go ahead and do that. And the way we do that is we basically highlight the controller. So my row controller here, bring out the side panel again, and instead of the attributes inspector, we can go to the identity inspector. So it looks like a little driver's license, I suppose. And then here we give it a class. So this is how we associate my row controller with my row controller class. And you see it's dropped down. You can also type in and it'll autocomplete. So my row controller class. Okay, so now it is associated with the row controller class. Okay. Now, this class, this table row class, will control whatever's inside of it. So that means I'm going to basically bring in another label object again. So label, okay, bring it in, put it into the row again. And so if I pop this back out, we see that, okay, so now my row controller contains a group. Within the group, there is a label. And yeah, it's a lot of panel navigation here when you're setting this up. But let's go to, whoops, that's not what I wanted. Let's open up our assistant editor here. And I don't want to be on the interface controller code. I want to be in the my row controller class. Right, so the controller class here, this is responsible for the objects inside the row. That means if I ever want to change what the label is showing, I'm going to want to associate it here with the object itself, so with the class. And we'll say the my label here, that's what we'll call it. Okay, it's a WK interface label. Cool. And now we have an association. So the row controller class, it's basically responsible for the label. And that's about all we have in there right now. We have a group as well, but we're not really going to do anything with the group. So far, so good. But we still can't display data in our table. We need to do another step here. So let's go back to our interface controller code. Right. So all I did here was I brought the label as a variable with the IB outlet builder, and that's all I'm doing there for now. So we'll go back to the interface controller. And in our func awake, let's kind of give some shape to our table. We have to tell it how to build the table now. So first of all, I'm going to grab the table itself here. And the table, we're going to click and bring as an outlet in the WK interface controller here. So my table is what I'll call that one. Okay. And if you're wondering, hey, why do we do this for the interface controller? Why don't we bring table into my row controller? Well, it kind of makes sense when you think about it. So rows are inside of tables, and the controller is just responsible for its own little kingdom, basically. Whereas a table we configure on the interface itself. Okay, so now that we have our my table outlet, we can basically set it and configure it. So just to do a simple setup here, we can kind of grab it, my table, and if I do dot here, we can see the methods that are available to us. Right, so you can see there's insert rows, number of rows, for example. And the one we want is this one. So as you can see at the top here, it says creates the specified number of row controllers of the same type to use in populating the table with data. Now what does that mean, of the same type? Well, it means we can have multiple of the same row controllers. So if they have similar data, it just basically creates a whole bunch of instances of it. But let's not get ahead of ourselves here. So first of all, let's just set up a table with, I don't know, 3 rows, for example. And the row type, this is where we give it the name, the identifier. So my row controller. Right, so that's the row type. So my row controller. Okay, so this, in theory, should work. Let's see what it does, though. Right, so assuming this works, then we'll just have to figure out how to get data into the actual table. And from here, it's not so complicated. And let's just wait for this to load up here. Okay. Hey, there we go. So we can see it told it. We told it to create 3 rows of type my row controller. Right, so that's not so bad, right? We just have to understand how to create kind of a subclass here. Let's figure out how to get it to display some data. So what we can do is we can basically create an array here, and then we can kind of iterate over the array. So let's say, what do we want our table to display? Let's say we want it to display foods. Right, so you know what? We'll just do one of these. So we'll say apples, oranges, bananas, grapefruits. What else here? Strawberries. Okay, and oranges. And you know what? These are all fruits, so we'll say fruits. Okay, and now basically we just need to tell it how many rows to use and how to display the info. Right, so right now all we're doing is we're creating the table with the rows, but we're not putting anything into the rows. Now we can tell it how many rows to make. We know there's 1, 2, 3, 4, 5. But the more logical way would be to say, hey, take the number of objects in fruits and just give us however many we need. So this will give us 5. So it just goes through and it counts how many different objects there are inside the array. And of course, each of them will be of type myRowController. It's our only controller anyway, so that's all we have the option to go with. Okay, so we're configuring our interface object. Basically, we can just write a for index fruit. Right, so these are kind of our placeholders. And we're going to be looking for these, right? So index and fruit in fruits.enumerated. Right, so this will basically, it tells us here actually, return the sequence of pairs, n and x. N represents consecutive integers starting at 0. Hey, that sounds like it's good for an index for us. And x represents an element of the sequence. Right, so we're going to enumerate over our fruits array. And we will basically define our rows in this way. Right, we're just kind of looping over our data. Pretty standard stuff here. So we're going to say let row equals my table dot row controller. And this is what we want. So row controller at a certain index. So the integer is basically at whatever index we need. That means we can say at index. And we'll do a force downcast here to make sure that it's using my row controller class, right? We call that my row controller class. Okay, so just going to make sure it goes to our my row controller so that it knows what controller to use, right? Next, we just say, okay, so row dot my label. So why my label? Well, it might help if I actually pull up our controller over here on the left. So I should be able to go up here. Yeah, so here's our controller class, and we have our my label object there. That's why I can call row.myLabel. Can you guess what's next? We've seen it a million times. Set text. Right? And what is the text we want to set? Well, consider this. So the first pass is going to be position 0. It's going to create a row for apples, and we want to set the text for that index as well. Right? So we can just say whatever item is at this index, which will be our fruit. Right? So that's our kind of placeholder name we gave it here. And so this should allow us to kind of iterate over our fruits, and our code is going to kind of talk to itself here, figure out what to do, and it should then populate the label. Let's see if it works though. Fingers crossed this will work. And as you can see, it is kind of a bit more complex, right? We have to understand a little bit more about classes and how they kind of talk to each other, but this should work. Okay, wait for that to load up here. Hey, there we go. Pretty neat. So I'm basically scrolling down. I can kind of tap on it. It doesn't do anything right now, but it is tappable. And there we go. So we just set up a very basic table. Now there's other ways we could have done this, but for a very basic table, this is essentially the steps you're going to need to take. And you know what? In for a penny, in for a pound. So let's make it a little bit more intuitive to set the actual text here in our loop. So what we can do is over here where we have our variable, my label, let's create an observer. So we can basically say something like this. So var label text will be of type string, and initially will just be blank, but the observer will set. So it's going to detect when it's trying to be set, and we'll say self dot my label dot set text, and it's going to take in basically let's see, new value. Okay, so basically this observer, it's going to detect if there is a change, and then it's just going to do will set for that change. So now all we need to do is instead of row.mylabel.setText, we can say row.label text equals fruit. Okay, whoops. And so just a bit more intuitive, and now our code is a little bit more discrete, right? So this is doing a specific thing, and this is doing another specific thing. And it looks like there's an error somewhere, and I think I just forgot to close one of these off. Okay, yeah, that should do it. Let's test it one more time, but now our code is pretty neato, in my opinion. All right, build succeeded. That's always a plus. Wait for it to load up. And here we go. All right, awesome. Cool. Now that we've added rows to our table, let's figure out how we can add some more. So for example, right now we're just adding as many rows as we need and kind of populating them in that way. But let's say later on you want some way to be able to add rows on your own. And there's actually a pretty easy way to do that. So for example, if we grab my table, right, referring to our table here, we can kind of look through this, this autocomplete stuff to see what will work for us. And we can actually see here, we can insert rows, we can remove rows. Let's try first of all inserting rows. So you can see it allows us to insert rows, and it takes an index set, and it also is going to take the row type. So index set, what that would look like is something like this. Index set, and it looks like a range basically, and this will insert the rows between whatever index set you use here. So for example, we have 1, 2, 3, 4, 5 rows. So let's say we wanted to insert it between I don't know, the fourth or the third and the fourth row, for example. So we can say 3 like so. So this will allow us to insert rows between 3 and 4. So not including 4, right? Dot dot less than 4. Okay, so this is going to allow us to insert rows, and with row type we do want to specify what row type. Of course we only have the one, but it's going to be my row controller. Okay, so this will insert one row essentially. Let's see what it does. And we will wait for it to load up. Okay, so 1, 2, 3, and then it inserted our row here because we only gave it an index set that has a range of 1 basically. If we gave it a bigger range though, so let's see if we did, let's see, 3, 2, 6 instead. You know, let's see what that'll look like. All right, so just kind of playing around with these numbers with index sets and seeing what it does. Okay, build succeeded, and we'll see what this looks like now. Any minute now, there it goes. Okay, so label, label, label. Right, so it created 3 because it went 3, 4, and 5, and it does not include 6. Right, so that's how you can use label sets. Now, if, for example, you wanted to set content as well, so right now it's just a blank label, well, that's pretty easy to do as well. So we can basically do like we did above, but a slightly different way. So we can still use a for loop. So we can say for, let's see, index in 3 dot dot less than 6. And then what do we do with this for loop? Let me put it on a separate line. Well, we're basically going to loop through again. So you know what? Let's make like a counter here. Our counter will start at 0, and every time we loop through, we will increase the counter by 1. And we will also say let inserted row equal my table dot row controller at what index? Well, we're starting at the index 3, right? Because this is going to loop through the range basically. So it's going to start at 3, it's going to go all the way up to 6, not including 6. And this will allow us to insert for every row we have there, right? We're just kind of hard coding it in, but this should work in any case. And then we can say inserted row dot label text equals, and let's do one of these, counter times. All right. And looks like I forgot to do my downcasting here, so my row controller class. All right, so now it's going to understand what we want it to do. Let's test it out. Let's see if it works. Right, so a lot of this is playing around with indexes, figuring out where is what in the table so that you can understand how to manipulate it. And this should show us what we want to do. And each label will be slightly different here. All right, so there we have 1 time, 2, 3, and then it just keeps going. All right, so we just inserted it wherever we needed it, and that's kind of nice. Right? You could also just insert it at the end if you wanted to, but if you wanted to insert in between, that's what this would look like. Pretty straightforward, really. Same as we're doing up above in essence. And if we wanted to be maybe a little bit more logical and modular with our code, we could do something like this. Var index set equals an index set with those values that we pass in. And then we just pass it in here instead. Index set. And then here we can just tell it to use that as well. Index set. It makes a little more sense this way. Yeah, I guess we can make it a constant. No problem with that. Whoops. All right, so this should work as well. And this way, if we ever need to update the values, we just need to update it in our index set here. We have our table, we are able to insert rows and then insert additional rows. Let's look at some other neat things we can do. For example, we can say myTable.scrollToRow, and you just give it an index of the item you want it to scroll to. So let's say we want to go to the item at index number 5. What this is going to do, pretty obvious, right? It's going to go to this row as soon as it loads into view. In this case, it's going to when it loads into view. So that's pretty handy if you want to start off, say, somewhere specific in your table. So it's kind of hard to tell, but it did scroll down to the item that's in the 5th index spot. All right, so 0, 1, 2, 3, 4, 5. So scroll down to this one. You could put this on a button press, for example. In fact, why don't we do that just to kind of see what it looks like here. So we'll bring in a button, and we'll just add it so it's outside the group. And let's add a function to that button. Let's put it somewhere like here. Make it an action. My button. Okay, and then we just put this code in there. And then we can actually watch it in action. Right, so table, other than the initial difficulty in terms of setting it up, it's pretty similar to pretty much any other object. You just have to kind of know how to manipulate it. So build succeeded. Let's make sure our button's actually working. Okay, there it goes. Okay, so let's go down to our button. We'll hit it. And I think it's already on the 5th item. So let's say if we put it, scroll to 1. Actually, let's go to position 0. Let's see what that looks like. Okay, didn't account for the fact that the button would be at the bottom of the screen already. Alright, so let's wait for this to load up. There we go. Okay, we'll go down here, hit the button, and you see it scrolls up back to the 1st item because it's in index position 0. Pretty nice. Now what else can we do? Let's try something else with our button. So we can say my table dot remove rows, and it takes an index set. So how can we give it an index set? We can just hard code something in like we did up above previously. So we can say, oops, let me put that back. Index set. Let's say we want to remove the items in these positions, for example. Right, so when we hit the button, it's going to remove those rows. And you can probably imagine what's going to happen here, right? But it's always good to test it out. And it really shows you, like, tables, they're pretty easy to manipulate as well. Alright, so let's hit the button. Okay, it's kind of hard to tell, but hey, it got rid of those other items, right? So pretty simple. And we can even kind of tinker around with the logic as well. So, you know what, let's put the index set and declare it up here. Okay. And then we can say var switched equals false. And you can probably imagine where I'm going with this, but let's just do it anyway here. So we'll say switched equals the opposite of switched. And if switched, let's see. Well, let's do this. Okay, so if switched, we will basically insert a whole bunch of rows. Else, let's see, where am I putting this? Probably want to put it here. Else, we will just remove the rows. Okay, and let's see. Yeah, this looks okay. This should work. Let's try it out. Alright, so build succeeded. Give it a second here. Okay, let's hit the button. Cool, so it added them. Let's hit it again. Removed all except the last one. Let's hit it again. Neat. All right. So that works. What if instead of this though, we wanted to just, when we hit the button, we want to add one row at a time. So how can we do that? Well, let's kind of erase the work we just did and reconfigure our button here. Okay, so I got rid of that variable, get rid of this one too. And yeah, I'll just erase all of this basically. Okay, so when the button is hit, we want to just add one row at a time. What we can do is we can say my table dot insert rows at index set. So what's our index set going to be? Well, it's going to look something like this. For our index set, we know what we're passing in initially, right? We're passing in our fruits array, which means we can just figure out how to give it an integer. Fruits.count dot dot, not including fruits.count, plus 1. Right? So basically, no matter how long our fruits array is, we're always going to be able to add to the end of it. And with row type, my row controller, of course. Okay, and then anytime we hit the button, it should insert a row at the end of the initial fruits row items. Let's test it out though, make sure it works. Okay, build succeeded, that's nice to see. Alrighty. There we go. So we're adding one row at a time. It's kind of hard to tell, but it's adding it at the bottom of strawberries every time. Just because that's where we're telling it to insert the rows, right? That's what we use for the index. Now, if we wanted to add to the end of the row every time, so the end of the table, that's a pretty simple fix. There's a couple ways we could do it, but probably the easiest way would just be to add more strings into our fruits array. So first of all, we need to change it from a constant to a variable. And this way, we can say, so every time we hit the button, we will just say fruits dot append, and we'll add a new element. And I guess this can just be any string really. So this is just as an example. And this is probably the simplest solution to kind of solve that minor issue. So it kind of makes more sense to me anyway to add rows at the very bottom instead of somewhere in the middle. But as always, it's up to you to implement this however you see fit. We'll just make sure this is working though. So adds it after strawberries. This should add it at the bottom of label. Yeah, exactly. So, we're just kind of manipulating our fruits array, and depending on how you get your data, you might want to solve this in a different way. Another option you might want to look at is, for example, you could say var index to insert at, and this can just be an int. Okay, so and then we initialize it in func awake, for example, because you can't really do fruits.count when you're initializing it up there. And we can say, let's see, index to insert at equals fruits.count. Okay, and then down here, we'll probably have to also initialize this to 0. And that'll get rid of that, hopefully. Yeah. Okay, and then down here, instead of appending to our data source, like let's say we don't want to change fruits, we want to leave this as a constant because we don't want to be able to alter this. Well, in that case, pretty simple, right? So we can just increment index to insert at plus equals 1. And then here, instead of fruits.count, we can just use our index to insert at. And same here. To insert at plus 1. Okay, this should achieve the same results, and this would allow us to not modify our original data source, which could definitely be desirable depending on what you're doing. Right, multiple solutions to every problem, just like everything else in code. Okay, so here we go. There's 1, there's 2. Awesome, working as intended. Let's say you wanted to add a button to remove the rows that you just added, for example, or maybe every row eventually. Well, let's go ahead and do that. So we'll add another button in here. And this one, I'm going to rename this while I'm at it. Add. We'll add another button in right there. This button will be remove. And we'll connect this with an action like so. So action, my remove button. I actually just call it my second button. Second button. All right. First things first, we'll grab the index to insert, and we will do minus equals 1, keeping in mind that we are using zero-based indexing here. So next we will just say, index to insert at, it should be. My table dot remove rows. And what's our index set? Well, we are going to basically use the same as we have up here. Okie dokie. So this should allow us to add and remove at the end of our table. And if we click this enough, we'll eventually get up to the point where we can delete the fruits as well. So let's try it out here. All right, so make sure this loads up. And we have to do -1 because we have to kind of take a step back from where we were initially, because we have to tell it the row we want to delete on is kind of -1 of the one we just added. All right, so add. Okay, so we have 2, remove, and now we can even remove our other items. Cool. And so now that's our add and remove button. So this might be useful in a number of areas, right? Maybe the user, they can put in some kind of grocery list, for example, and as they're in the grocery store looking at their watch, they can remove items, they can add something like so. So that's how that would work. Now there is one issue with the code as we have it, which is, you may have spotted it already, if we remove too many and then we try to hit again, or even add later on, it's not going to know where to insert and where to delete, because it's going to be looking for rows that are non-existent or maybe even negative rows, which doesn't really make sense. So if I remove, and this will crash once I hit it again here, maybe 2 times. Okay, so it crashed. And the error message is kind of cryptic, but it does highlight the issue. Right, so it's trying to remove rows that don't exist. And it's going to be going into the negative at this point. So how can we solve that? Well, it's a really simple fix, actually. And we just basically have to do a quick check here. So if index to insert at is less than 1, we will just return from the function without doing anything. Right? And otherwise, it's just going to run the code here. Right? So this should solve our problem. Let's test it out to make sure. And now we can delete as much as we want. And we have this check to make sure that it's not going to crash, right? No one wants an app that's going to crash. And it just kind of shows the importance of testing all the permutations here of your possible code. All right, so let's try removing these. Remove. Okay, I'm going to hit it a bunch of times. So far, so good. No crashes. And currently, index to insert at should be 0. Let's try to add. Okay, so it's doing as expected. It's adding in a predictable way and removing the way we initially intended as well. And that is great. Other useful things you can do in terms of getting info from tables is to figure out the number of rows, for example. So if we want to see anytime we delete the rows, for example, actually no, let's do anytime we add a row, we want to maybe print out to console how many rows we have. Well, that's dead simple. My table dot number of rows, and as you can see here, this tells you, it returns the number of row controllers available for you to retrieve. All right, so let's test this out. And you can probably imagine how this would be useful, right? If you have a certain number of rows, you might do one thing, versus if you have a different number, do something else, or display them in a different way perhaps. Let's just make sure this is working though. Load it up, and I'll pop up the console down here. And so now when I hit add, okay, number of rows is 6. Again, number of rows is now 7, right? 1, 2, 3, 4, 5. Yeah, it looks accurate to me. And you can put some logic behind this too. Like for example, if my table dot number of rows equals 5, then we can do something, for example. So we can say print hello to the console, and we can then say else print goodbye, for example. Let's see if that works. And yeah, like I said, you can probably imagine how this would be useful in other circumstances as well. Once you get like a lot of rows, your tables might get a little bit more complicated. So you're going to want to have some logic to be able to figure that out. All right, let's pop up our console here. And let's see, so we'll add goodbye. Now if we remove a whole bunch and add one, and then another, and then another. Okay, so now we have 5 number of rows. Right, 1, 2, 3, 4, 5. And this is set to go off as soon as we have exactly 5. Right, you could also do other simple logic, like if it's greater than 5 or less than 5 or whatever. And that's how you can use dot number of rows. Another useful thing you can do is you can tell what row controller is being invoked for any given row. So for example, if we say my table dot row controller, and we see it takes an integer, which is going to be the index, and it shows you what row controller it is using for any specific row. Now right now we only have the one row controller, but if we had multiple and we want to have kind of different logic depending on where it is, we could definitely do that. So let's see, let's find out what row controller is at index position 5, and we'll print that out to the console, see what that looks like here. Okay, we'll load that up, and once your table starts to get more complex, you're going to have multiple row controllers, so it's going to be useful to tell which one is being invoked at which points. All right, so there that goes. Pop this up down below. Let's go ahead and try it out. Add. Right, so it says my first WatchKit extension dot my row controller class, and this is just a memory address. So it's telling us the row controller is this, my row controller class, and that's going to be useful as well, right? So this is something you can use to your advantage.